Welcome everyone. Today, we will explore the modeling stage and machine learning. Our objective is to understand the three main types of machine learning: supervised, unsupervised, and reinforcement learning, while also grasping the role of train-test splits and the modeling stage in building effective machine learning solutions. By the end of this session, you will have a clearer idea of how these elements fit together and their practical applications. Let's begin with the structure of artificial intelligence, or AI. AI is the broadest field that encompasses all systems designed to mimic human intelligence. Within AI, we have machine learning, which focuses on enabling systems to learn patterns from data to make predictions or decisions. Machine learning is divided into three main categories. The first is supervised learning, where the system learns from labeled data. For example, if you want to predict whether an email is spam or not, you provide the model with emails labeled as the spam or not spam during training. Supervised learning also includes regression tasks, such as predicting house prices based on historical data using algorithms like linear regression or random forests. Next, we have unsupervised learning, which works with unlabeled data. Here, the goal is to discover patterns, such as grouping customers with similar buying habits or identifying fraudulent transactions. Algorithms like k-means clustering and PCA are commonly used for these tasks. Finally, we have reinforcement learning, where the system learns through interaction with an environment. It improves by receiving rewards for successful actions and penalties for mistakes. This type of learning is often used in robotics or game-playing AI, such as training a chess bot to make optimal moves. Beneath machine learning is deep learning, a subset that uses neural networks with multiple layers to process complex data like images or natural language. Examples include convolutional neural networks for image recognition and recurrent neural networks for sequential data like time series or text. Now that we have an overview of machine learning types, let's dive into the modeling stage, a critical step in developing machine learning solutions. The modeling stage involves four main steps: selecting an algorithm, training the model, validating it, and optimizing its hyperparameters. The first step, selecting the algorithm, depends on the type of problem you are solving. For classification problems, algorithms like logistic regression or decision trees might be used. For regression tasks, linear regression could be appropriate. Choosing the right algorithm is crucial as it directly impacts the model's performance. Next is training the model. Here, we use the training dataset to teach the algorithm patterns within the data. For example, if you're working on a house price prediction model, the system learns from historical data, such as square footage and location, to predict prices. The third step is validation. This involves evaluating the model's performance using a separate validation or test dataset. By doing this, we ensure the model can generalize to new, unseen data rather than just memorizing the training set. Metrics such as accuracy, precision, or mean squared error are used to measure performance. Finally, we tune hyperparameters, which are settings like learning rate or tree depth. Adjusting these parameters helps optimize the model's performance, ensuring it balances accuracy and efficiency. For example, if the learning rate is too high, the model might overshoot optimal solutions. If it's too low, the training process could take too long. The modeling stage is critical because it balances training and validation, avoiding overfitting or underfitting, and produces a model that works well in real-world applications. To make the modeling stage effective, we rely on train-test splits. The dataset is divided into two parts: the training set, which constitutes about 70 to 80% of the data, and the test set, which makes up the remaining 20 to 30%. The training set is used to teach the model patterns, while the test set evaluates how well the model generalizes to new, unseen data. For instance, in a spam detection system, the training set includes emails labeled as spam or not spam, while the test set consists of new emails the model has not seen before. This process ensures the model doesn't overfit or underfit and performs accurately in real-world scenarios. In summary, we've explored the structure of AI and machine learning, delving into supervised, unsupervised, and reinforcement learning. We've also covered the four steps of the modeling stage: selecting an algorithm, training the model, validating it, and optimizing hyperparameters. Finally, we discuss the importance of train test splits to evaluate a model's generalizability. Machine learning is a fascinating field that bridges theoretical knowledge with practical applications. Whether you're detecting spam, predicting house prices, or training a robot, understanding these foundational concepts is essential to success. Thank you for your attention, and I hope this session has clarified the essentials of the modeling stage and machine learning.